Hello, this is Dr. Ryan Johnson with Introduction to Statistics, and we're covering section 4.2 today. So 4.2, this chapter 4 is all about confidence intervals. So last time we learned about what confidence intervals are. We had a very simulation-based view of how to find them. And so for this section, we're going to do more of a theory-based way of finding confidence intervals. And for this section in particular, it's going to be single proportion. Next section we'll talk about what we do with quantitative data. Okay, so hopefully you should have already done the discussion post to get us some class data for the end of our worksheet. And you should have done this reading. You should have also paid attention to what things are in bold. So when we talk about the standard deviation of p hat, is the standard deviation of p hat meaning like the standard deviation of how the samples end up. And then we had kind of learned about the 2 times standard deviation method from last time. Well, we learned more about it this time. The 2 standard deviation method is basically you take your statistic and then add and subtract 2 times the standard deviation of the samples of the simulation samples. And so then we would call that thing in the brackets the margin of error. And then so then you learned about how the standard deviation, the theory-based formula for finding standard deviation of p hat is to take the population proportion times 1 minus population proportion over n, square root of that. And then, but we often don't know pi. Pi is a Greek letter. It's a number we often don't know. So it's better to use a number we do know. So since we don't know what pi is, we can use p hat instead and still be fairly close. And so then when we're doing the confidence interval, it ends up being, so we'll call this standard error of p hat. And so then p hat times the multiplier, which was usually 2, but sometimes other numbers, times standard error of p hat, which is this formula right here. And then that multiplier can be different. So for 95% confidence, it's 1.96, which is basically 2. So 2 is usually good enough there. But if you want a 90% confidence, you're talking 1.645. A 99% confidence, you're talking 2.576. So the multiplier can be different based on what sort of confidence you're going for. And so then just remembering that for confidence intervals, it's statistic plus or minus margin of error. So this takes us to the worksheet. So here we have, we're going to look more at the proportion of Americans who live in a different state than where they were born. So we're introduced to the General Social Survey, and there's a link to it if you want to go to it. And then, so then for number 1, identify the population and the sample in this survey. The population is the big thing, so you don't know how many people are in there. You just are kind of describing it. Whereas the sample, it should be a number. It should be a number that was said in the paragraph above. Number 2, is it reasonable to believe that the sample of 2,348 adult Americans is representative of the larger population? Explain why or why not. Well, if in one of your previous classes you've dealt with the General Social Survey, feel free to use that. But if you've never heard of the General Social Survey, then feel free to use that link. So that's a footnote. It's right there. You can follow this or just Google General Social Survey and do a quick checkup on it. See if it seems like they have good methods. Okay. So explain why 36.2% is a statistic and not a parameter. What symbol would you use to represent it? So this is a review of talking about how what are statistics, what are parameters, what are the symbols we use. All right, now number 4, identifying words, the parameter that the Gallup organization was interested in estimating. So what is the number, the proportion of blah, 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 blah. Okay, so for number 6, number 5, is it reasonable to conclude that exactly 36.2% American adults currently live in a different state from where they were born. Explain why or why not. The key word there is exactly. That's a key word for that question. Okay, so although we expect pi to be close to 0.362, so number 6 gives you a good hint for number 5. We realize there are many other plausible values for the population proportion as well. First, consider the value of 0.382. Is this a plausible value for pi? Now, this is a stats class, so we don't want you to answer that question just based on your feelings. We want you to actually do some calculations. So use the one proportion applet. So you would go here to applets, which would take you there, and the one proportion applet, which is here. And so then use one proportion applet to simulate random samples of 2,348 people from such a population. From such a population, so first I know that my number of tosses will be 2348. And so then here, this number is not 0.5. There are two numbers given. One is the sample, so 0.362 was the sample, and then the question was around 0.382. And so the questionable number is the one that's a hypothesis. That's the one that would be the null and alternative hypothesis. So the null and alternative hypothesis one is the one we simulate around, because when we're doing simulations, we're assuming the null hypothesis is true. And then here, you want to do, for this one, you want to do as big a number as your computer can handle. So my computer can handle about 20,000. Your computer might need to do a lower number. You'll know because it'll kill the web page if you do too big of a number here. All right, so don't do that. Draw the samples. It'll take some time. There we go. And now we put in our statistic. We measure our statistic according to the null population. So the statistic was 0.362. So we'll count, but then we're not counting that way. We're counting more extreme, and we'll do two-sided. Okay. So that means that I would get 0.0487. So hopefully you know what to do, whether to reject or fail to reject based on that number. And that if we reject, that means it's not plausible. That means our original number is not plausible. If we fail to reject, then it is plausible. Okay, so also check the summary stats box to report the mean and standard deviation of the null distribution. So let's see, hold on. Yeah, we want to be talking. So remember to like go back and forth between these guys. So here we've got the mean is 0.382. Okay, that's just like that. Look at that. Standard deviation is 0.010. Okay. So yours might be slightly different, but make sure to do that. So now consider 0.5. Is this plausible value for pi? So I'll let you guys do that. So, you're checking 0.5 right there, and checking if it's plausible. Okay. Now, the next paragraph tells you how you should have answered. Clearly, 0.5 is going to be too far from p hat. But how far is too far? So that's what we're talking about with confidence intervals, basically. Oh dear. Okay, where we are. Number 9. Okay. So reconsider our first guess of pi equals 0.382. How many standard deviations is 0.362 from 0.382? So we're talking standardize the value by looking at the difference between 0.382 and 0.362 divided by the standard deviation you found in exercise 427. So look at this standard deviation and how many standard deviations is this number different from that number. Okay, so that's a nice little math question there. So key idea, when a sampling distribution is bell-shaped, as your null distribution should be for the study, approximately 95% of the statistics in the sampling distribution will fall within 2 standard deviations of the mean. This implies that 95% of sample proportions will fall within 2 standard deviations of the parameter, which means that pi is within 2 standard deviations of the observed sample proportion for 95% of all samples. So, we construct a 95% confidence interval of plausible values for a parameter by including all the values that fall within 2 standard deviations of the sample statistic. This method is only valid when the sampling distribution follows a bell-shaped symmetric distribution. Well, later on we'll tell you more things of how to determine that, but eyeballing whether it's bell-shaped is a good start. So we call this the 2 standard deviation method for a 95% confidence interval. So the long run proportion or population proportion, pi, as in symbols is, pi is somewhere in p hat, so your sample statistic, plus or minus 2 times the standard deviation of p hat from the null distribution of your simulation. Okay, so this 2 times standard deviation, that's called the margin of error. All right, so how do we find the standard deviation to use for the 2 standard deviation method? So, how did the standard deviation you found in exercise 427 with pi equal and in exercise 428 with pi compare? So, when you did 0.5 here instead of 0.382, did you have the same standard deviation or almost the same or very different standard deviations? Okay? And then the paragraph afterwards tells you how you should have answered. So then, determine a 95% confidence interval using the 2 standard deviation method. So first calculate 2 times standard deviation per sampling distribution. So 2 times this number right there, using 0.5 in the simulation. So use the 0.5 number, not this one number, but it might be around the same. All right, use this standard deviation to produce a 95% confidence interval for pi. So then use the formula. So for part B, use this formula. Okay, and then for C, interpret the confidence interval. So here, remember that statistics is a wisdom class that uses math, not just a math class. And so it's really important that you can interpret the numbers using all the words that relate to the study. Okay, don't just say don't just tell me the average proportion is probably between this and the, this is a study on people, Americans, who are answering whether or not they're live in the same state as they were born. So use that language, the language of the study, in your answer to part C, using full sentence or 2. Okay, I'm going to pause here. We'll start the next video in a second.